Good afternoon. My name is Jordan Woods. I'm the director of the Deterministic Ethernet Technology Group in Analog Devices. I'd like to also acknowledge my colleague Tom Weingartner, who was instrumental in helping me put this together. I'm here to talk to you about the future of TSN in automation networks. It's a future I'm very optimistic about. Part of my job is to participate in standards and industrial consortium work. I'm a voting member of the IEEE 802.1 working group, a member of the TSN task group. I'm also the editor of the 60802 IEC IEEE joint project intending to create a TSN profile for industrial automation. And I can tell you, based on those experiences and based on my own experience, I've been serving the automation market in some way, shape, or form for a quarter century, that there's an unprecedented level of cooperation among automation players with respect to deploying TSN and TSN technologies. And there's good reason for that. So the first thing I have to do is make sure it's clear that although I am an active member in IEEE and also the editor of the 60802 joint profile, I am not speaking on their behalf. I am speaking as an individual contributor and as a participant and a stakeholder in TSN technologies. So TSN and Industry 4.0 are often linked. There's a good reason for that as well. So we'll start with a discussion of Industry 4.0, and you see on the left of the diagram the traditional Kraken pyramid for industrial automation. And of course, what you have down at the field level are devices that are typically connected with point-to-point field buses, sometimes with Ethernet, but generally with technologies that do not interoperate and cannot coexist on the wire. And that leads to a certain amount of data isolation in the network. Yes, you can use protocol gateways, but these devices, generally speaking, are not directly addressable, right? And that is kind of contrary to the vision of Industry 4.0. So edge devices have to make that transition to the edge of the network, right? And of course, we have to make sure that that's a convergent network, that standard 802.1 technologies are down at the edge. And of course, having more nodes and more addressability on the network leads to potential security issues, and we have to be certain that we address those. So why Industry 4.0? Why the smart factory? Well, I mean, primarily, it's because we want flexibility in manufacturing. We want to maximize uptime. We want traceability to improve our compliance to regulatory demands. We want to be able to respond very quickly to upsets on the floor, right? These are all problems that exist today. They're all problems that are addressed in some way, shape, or form. But from a flexibility standpoint, from an uptime standpoint, I'm going to say that industry's falling a bit short of these goals. And that's what Industry 4.0 is about, and that's what standards-based technology in the automation network is about. So this is the classic circle diagram from IEC, which basically talks about the interoperability in a 60802 network. And perhaps a better word than interoperability would be coexistence, right? No one's expecting a Profinet device to talk to an EtherCAT device to talk to an Ethernet IP device. What we are expecting is that they can share the wire. And they can share the wire in a way that guarantees their contract on that wire to make sure their control traffic is not interfered with. That's what time-sensitive networking is about. I will also point out that nothing prevents a device from supporting more than a single protocol. So for instance, it's very common today for a device to support one of these industrial protocols and then support something like FLC or OPC for machine-to-machine level communication. So again, it's that scalability and it's that coexistence that enables that, that breaking down of these data islands that I spoke of. So I realize this is a bit of an eye chart. That's deliberate on my part. One of the misconceptions I run across quite often in discussions about time-sensitive networking is that time-sensitive networking is a standard. Well, really, time-sensitive networking is one bunch of standards. It's a lot of standards, right? And you see a list, and by the way, this is my attempt at a comprehensive list. I'm not guaranteeing I haven't missed something that somebody would consider a time-sensitive networking spec, but this is a pretty comprehensive list of what's on there. The other thing that I hear a lot is that time-sensitive networking is a long way out, that the specs aren't done. Now, that's true and not true. I'm going to make a statement that most of the TSN features which affect the industrial use case are done. They are published standards. Most of the TSN specs that affect the industrial use case and impact silicon, I should say, are done. So the hardware features are largely done. In the red circles down below, you see a couple of exceptions. There's some work going on of another type of shaper, the asynchronous traffic shaper, and while I'm not directly aware of a use case for that in industrial automation, I can see the potential. The other is some extended stream identification functions. For those of you not familiar with that, that would allow you to take brownfield traffic in a general sense and map it into a TSN stream so that it can be routed in a TSN infrastructure and its traffic specifications guaranteed. So those are in work, okay? The other ones you see here are largely not hardware related. They're upper layer, okay? So the other reason that was an eye chart is because TSN is a lot of different things to a lot of different people, or more accurately, it's meant to address a lot of verticals, okay? So what are the tools that we select from that toolbox in order to ensure we have an interoperable industrial automation network? Well, that is the basis of the work for the 60802 profile, right? Is to select that common set of tools, those common sets of specifications and mandatory features for an automation network. The common management model, right? Because again, one of the assumptions about this is that it's a managed network. We have to scale this network. Our world has gotten bigger, right? So that's what the 60802 profile is about. So what I have here on the left is sort of further making that point. These are kind of some of the standard features that also impact hardware that are useful for the industrial use case. Now, this isn't necessary. This is a representative list, not a comprehensive list, but that prior list, pretty much all the hardware features are done, right? So what's missing? Well, there's a hole in management. And what do I mean by that? The management variables for all these features are defined. There's lots of good management protocols on the market. You know, the industry seems to be trending towards some type of RESTful interface like NetConf or RESTconf. What's not done are the data models underneath, right? But again, there is ongoing work, a bunch of smart people working hard to get those data models in place. So I would consider management to be one of the holes right now in the TSN story, but it's being actively worked on, and the work is progressing quite quickly. Okay? So I talked about the coexistence of different protocols on the wires, and by the way, I have to thank one of my IEEE colleagues from Rockwell Automation who loaned me this graphic. I mentioned that what needs to be guaranteed with these common layer 2 networking mechanisms and with this common management scheme is essentially your traffic guarantee. You have some traffic specification that you need to meet, some cycle time, some delivery time, some amount of tolerable latency and jitter that you have to meet. So those guarantees have to be met, and they have to be met for all the traffic on the wire that has such requirements. So that's really what TSN is about, is ensuring fairness on the wire. And you've heard a lot of talk about this IT-OT convergence. What TSN does is it makes the toolbox common. Now, TSN is not a panacea, right? You still have to solve the control problem, right? It's not solving it for you, right? So I think what this does in terms of the cultural divide between IT and OT is it gives them a common language to speak, right? So that they're understanding each other when they talk about the various mechanisms that are needed to provide these guarantees on the wire. That isn't to say that there isn't going to still be some, well, I'm all worried about my enterprise and I'm worried about making sure my control network is up. Those are cultural divides that'll take some time to mature. But what it does say is that now at least they're speaking the same language, okay? Now they're talking about a common set of management mechanisms. And the other thing that I think this does, in a world where the automation and control engineer workforce is aging pretty rapidly, it provides an attractive set of skills to bring in new blood, right? So again, this is one piece of the puzzle. I'm not here to tell you that TSN is the solution to Industry 4.0. I'm here to tell you it's a foundational technology for Industry 4.0. And in that spirit, right, you see down here various verticals, including industrial, with different profiles, but a common semiconductor and bridging product base to support those. And of course, part of that is the ability to commonly validate the silicon. And then, of course, the ability to have a one-stop shop model for conformance for industrial automation, for protocols. So, the ODVAs, the PIs, the EtherCAT technology groups of the world, they're not going away. They're going to be active participants in this, and they're going to want, for good reason, to be the conformance lab for these technologies, right? But what's needed is a common base and a common tool set to be testing against, and which the individual protocols can be tested on top of, right? There's good work going on in IEC CA right now to address this issue, as well as a couple of forums that are like AVNU and IEC that are attempting to address silicon validation. So this is what I would consider the other large hole in the TSN story. But again, smart people working on it, it's going to happen, right? The good news about all of these problems, really, I'm fond of telling my colleagues in IEEE that industrial automation players know more about deploying time-sensitive networking than anybody else, because they've been doing it for a decade or more, right? It's just a different layer 2 now, right? But largely, these are problems that we have solved before and that we will solve again, right? The difference is our world's gotten bigger, right? The network's bigger. We want to scale the network. We want to talk from the enterprise to the device. That's the part that's a little different, in which we can leverage what's been learned in enterprise for the purposes of the automation network. So, conclusion. I believe that achieving the goals of Industry 4.0 start with the foundational technologies like TSN, okay? So there has to be a fundamental shift if you want to converge and scale the network, and that's the benefit of standards-based layer 2. TSN and security are going to help eliminate the data islands, but security is a key piece. You absolutely have to ensure that these are secure connections, because they're no longer isolated by proprietary field buses, right? That's Ethernet on the wire. It's got all the same vulnerabilities as your PC has, and those have to be addressed. TSN standards, at least from a hardware perspective, and actually from a general perspective, are for the most part complete. One of the big ones that has been going on for some time is ASREV, the time synchronization standard. That just completed sponsor ballot, so that's nearing publication. They're all getting pretty darn mature. And the industrial profile, the 60802 industrial profile, provides that common toolbox, right, that we're going to need to ensure coexistence on the wire. So the other piece, the other big hole, is that adherence and conformance piece, right, which is also being worked on, right? We have to make sure that when I talk about scheduled traffic in TSN and some other semiconductor player talks about scheduled traffic in TSN, that means the same thing from the customer's point of view. And that's what interoperability and conformance testing are going to help us ensure. This future is coming into focus every day. I think one of the key messages I want to send here is that there are a lot of smart people working on this, and the level of cooperation in industry is unlike anything I've ever seen in my 25 years of serving the market. Now, the full vision of the smart factory isn't going to materialize overnight, right? TSN is a foundational piece, right? It's going to happen in increments, right? You're going to start seeing cells or machines come online that are based upon TSN and somehow are gatewayed into the larger network. But I think the future of actual TSN deployments is nearer than most people think, right? Vendors are going to leverage what they already know about the control problem, about management, about deploying control networks, and they're going to slowly scale their networks up. So I think the future of TSN, you know, I've often said it's not a matter of if, it's a matter of when. But I think when, at least in terms of these first incremental deployments, is less than a handful of years away. I think in 2 to 3 years, you'll start seeing practical deployments of TSN devices in industrial networks.